All right, so in our first dive into NodeZero, we talked about its big promise: your keys, your vault. But now we're going to pop the hood and really get into the weeds. We're talking about the cryptography that makes that promise a stone-cold mathematical fact, not just some catchy marketing line. So let's do this.
Okay, this quote right here, it just hits the nail on the head. It's the Achilles heel of pretty much every single password manager out there. Because when they get breached, and let's be real, it's a matter of when, not if, it's not just a little data leak. No, it's the whole shebang. Attackers walk away with millions of encrypted vaults, and the worst part? They have all the time in the world to crack them offline. That's a race you are guaranteed to lose.
So what's the real problem here? The model itself. It's totally broken. It's all built on this fragile idea of trust. You have to trust a company to be perfect. Perfect servers, perfect code, perfect employees who never make a mistake or have a bad day. I mean, does that sound realistic to you? You're literally handing over the keys to your entire digital kingdom and just hoping for the best. That's a massive gamble.
And that right there is the big question. It's the one that changes everything. What if you didn't have to gamble? What if you could build a system that just doesn't require trust at all? Imagine a world where your security isn't based on a pinky promise from a company, but on cold, hard, verifiable math. What if we could swap out trust us for prove it? Okay, let's dive into that. Section 1, the central vault problem. We're going to really unpack why that trust us model is not just a little leaky, it's a sinking ship. So check this out. On the left, you've got the old way of doing things, the problems. And on the right, you see how NodeZero flips the script? This isn't about slapping on a Band-Aid. It's a total redesign. Your vault on their servers? Nope, it's encrypted on basic cloud storage. And you, and only you, hold the keys. A master password that can be cracked? Gone. Replaced with a hardware-bound key. Unencrypted metadata? Not a chance. Every single field gets its own encryption. And traceability? Forget about it. You can see the theme here. It's about taking power away from the central server and giving it back to you. All right, so let's get into the first big piece of this puzzle. Section 2, your keys, not your email. This is about completely changing how we think about digital identity. Forget being defined by your email address. In this world, you are your keys. And trust me, that's a huge deal.
So what is this thing? A decentralized identifier, or DID. Think of it like this. It's a digital ID that you create for yourself. No government, no company, nobody gives it to you. You generate it, you control it, and no one can ever take it away. It's like your own personal cryptographic fingerprint, born from a secret that only you know. You literally become your own authentication server. And here's how that fingerprint actually comes to life. It all starts with a simple 12-word mnemonic phrase. That phrase gets put through this, well, it's like a cryptographic meat grinder. It goes through a bunch of steps, using super strong algorithms that are designed to make it incredibly tough. And out the other end comes your unique private key, your DID. The best part? This process is deterministic. It's like a mathematical recipe. You put in the same 12 words, you get the exact same key every single time. That means you can prove who you are on any new device, without ever having to check in with a central authority.
Okay, so you've got this super secure, cell-phoned identity. Awesome. But how does that actually protect your passwords? That brings us to Section 3, the fortified double vault. This is where we see a really clever design that gives you both convenience and ironclad security. You don't have to choose. So here's how it works. You actually have two vaults. First, there's your primary vault. This is what you use every day. It unlocks instantly with a hardware key. Think YubiKey or just your laptop's built-in passkey. And here's the absolute game changer. There is no master password. I'm going to say that again. There is no master password to be stolen, phished, or brute forced. It just doesn't exist. Then you have the recovery vault. This is your emergency backup, and you unlock it with that 12-word phrase. But there's a catch. And that catch is 30 seconds. Yeah, you heard me. To unlock your recovery vault, your device has to run this super intensive calculation 2 million times. It's designed to take about half a minute. Now, for you, when you're recovering your account, it's a minor one-time annoyance. But for an attacker who somehow got your recovery phrase, it's a nightmare. It means every single guess they make costs them 30 seconds. Trying to brute force that is just mathematically hilarious. It's not going to happen. Okay, so the vault is basically a fortress. We got that. But what about privacy? I mean, a lot of services, even if your data is encrypted, they know when you log in, how often, from where. They build a profile on you.
So that brings us to Section 4, the anonymous handshake. How do you sync your data without leaving a trail?
I mean, think about it. This sounds completely impossible, right? The server has to know it's you to give you your stuff, but at the same time, we don't want it to know it's you. How on earth do you get the service you need without the surveillance that usually comes with it? It's a real head-scratcher.
Well, the answer is this incredibly clever piece of cryptography called a blind signature. Imagine you have a note you want an authority to sign, but you don't want them to read it. So you put your note inside an envelope with a carbon paper lining. You hand them the sealed envelope. They sign the outside of it, but because of that carbon paper, their signature gets transferred onto the note inside. You take it back, pull out your now signed note. Later, when you want to sync, you show them the signed note. They see their own signature and go, yep, this is legit. But here's the kicker. They have absolutely no idea when they signed it. They can't link the token you just used back to when you got it. The chain is broken. Total anonymity.
All right, so we've covered security and privacy, but there's one more giant's question. What happens when you lose your phone or your laptop breaks? This brings us to Section 5, recover without compromise. How do you get everything back without having to rely on some company's customer support, which is really just a potential backdoor into your life? So here's the scene. You've got a brand new device, completely fresh. The only thing you have is that 12-word phrase you wrote down. And you know what? That's all you need. You're not about to fill out a support ticket or beg a company to give you your data back. You are about to take it back yourself. So let's walk through exactly how this works. Step 1, you type in your 12-word phrase on the new device. Poof! Your private key, your DID, is instantly reborn right there. Now here's the critical part. You use that brand new key to cryptographically sign a request to download your vault. You're not just sending a username. You're providing mathematical proof that you are who you say you are. The server sees that signature, verifies it, and only then does it let you download your encrypted vault file. After that, the 30-second key derivation thing kicks in, the vault decrypts, and bam, you're in. Full access. And this one detail is the absolute kill shot for the most common type of password manager attack. An attacker can't just find your encrypted vault file sitting on a server somewhere and download it to crack offline. It's impossible. Why? Because to even get the encrypted file in the first place, they would first have to prove they already have your private key. It's like needing the key to the safe just to be allowed to touch the safe.
So let's pull back for a second. When you add all this up, the cell phone identity, the keys that aren't passwords, the built-in delays, the anonymous syncing, what you're left with isn't just a different product. It's a completely different way of thinking about security. It's a true paradigm shift.
And it really boils down to these core principles. First, it's about cryptographic proof, not trust. The math speaks for itself. Second, user sovereignty. You are the boss. You hold the keys to the kingdom. Third, decentralization. Get rid of the giant, juicy central target, and there's nothing for attackers to go after. And finally, privacy by design. Anonymity isn't a feature you turn on. It's just how the system works. It really is the difference between renting your digital life from a big company and actually owning it. So I want to leave you with this one final thought. We've just seen how it's possible to protect your most sensitive secrets, your passwords, without having to trust any company at all. And if we can do it for passwords, it really makes you think, doesn't it? What else in our digital lives is built on this shaky foundation of trust? What else could be rebuilt on a foundation of solid mathematical proof?